All right, Anthony, let's do this in parts because I want to be detailed and clear in this diagnostic. First of all, let's start with the misfire. The misfire that's occurring only on cylinder number 8. It's not on multiple cylinders, but it happens on cylinder number 8. I have been running the truck for at least 30 minutes or so since you left. I did a quick loop around the parking lot, and when the truck was cooler than it is right now, because I have been running it for half an hour, the misfire was constant on cylinder number 8. However, since I started the engine, it's been happening for here's the amount of times that have happened. 2,000, almost 3,000 misfires measured. Right now, there's no misfire. Even if I increase the RPMs, there is no misfire right now. So, what this is telling me is that the cooler the engine is, the more prevalent the misfire is. Right? So now we have the information about that. What I would do to resolve that issue is the same thing that we did on the other truck. Do a tune-up, replace spark plugs, ignition wires, and ignition coils. And also, since we are here and since everything is going to be open, the deck is going to be open, we can also replace the injectors. I mean, it's a good time to do it. The injectors, I don't see any failure happening with them right now, but it could be a good time to do that. Since we are at 325,000 miles, that's a lot. I think we are reaching the upper limits of the OEM parts. So once we open the hood and we remove the spark plugs, I expect to find the spark plugs in the same condition as you saw before. Okay, that's the tune-up and the misfire. We have already tackled it. Now let's talk about the oil pressure. You didn't tell me anything about the oil pressure, but you have mentioned it before on the other truck. Again, due to the mileage. Let's see the specs according to the manual that I have here. That's going to be let's get over here. Let's go over to specs 60 engine. Here it is. I don't know if you can read it there. Oil pressure requested at 1,000 RPM is 22 psi. I'm idling right now at less than 7,000, and it's the oil pressure is currently sitting at more than 20 psi. At 2,000 RPM, it requests a value of 30 psi. And what I'm reading right now, let me show you. This is what I'm seeing right now. Almost 40 psi. It requests 40 psi. The maximum pressure that it requests is 33 psi. So we are doing good regarding oil pressure. However, once again, due to the mileage and the fact that we are here and we can tackle everything in one shot, I would suggest you to replace the oil pan gasket and also the seals related to the oil pump. Not because they are failing right now, but in order to avoid that happening in the future. Now, the other two fault codes that I read. Okay. By the way, here is the misfire on cylinder number 8. It's happening there. Here. There you go. Okay, that's happening right now. The two other trouble codes were due to the catalytic converter system being under the threshold of efficiency, or in other words, with low efficiency. Now let's go to the manual again and see what it calls for the oxygen sensors. I think you might have already heard about this before, or you know about this, but I don't know. I explained that to you anyway. There are two oxygen sensors on each side. Bank number 1 and bank number 2 have upstream and downstream oxygen sensors. The downstream oxygen sensors tell the computer, the PCM, they tell whether the catalytic converter is working alright or not. This is a new catalytic converter from 4H. What I'm showing you here is this is the inside. It looks like a honeycomb made of a ceramic matrix where there is a coating or a deposit of basically rare precious metals like rhodium, palladium and stuff. The main purpose of this catalytic converter is to reduce the amount of hydrocarbons after it. Okay, so this is where it has a plug where you put the oxygen sensor to monitor it. Okay, now when they say low efficiency, it tends to be because over time and over mileage and heat, this ceramic matrix tends to break and fall off. It turns into a dust that you see once you remove this. It's very likely that I see dust coming out of the inside because it's warm. Okay, and that's the reason you get a low efficiency reading and a low efficiency fault code. This is a new one. I'm going to show you a photo of the one that we replaced this for, the one that was damaged, that was worn. You're going to see that there is kind of an erosion going on. But furthermore, I'm going to show you the data that tells me that the oxygen sensors are good, but not the catalytic converter. Again, it's not that's not something that's going to cause you drivability issues, but that will prevent you from registering the vehicle one more time. The registration for this one is due on November 2024, so at some point you're going to have to do something about it, unless you are going to replace the vehicle. Now, what I'm going to show you is sensors number 2 on each side, or the downstream sensors. Okay, so let's go, and here is sensor 2 on bank 1 and sensor 2 on bank 2, downstream sensors. Okay, let me cancel the merge. Okay, here's the graphic showing you the status of the oxygen sensors. That's a normal operation. However, once I put the engine in load, because a load to the engine, they tend to oscillate more than they have to. Okay, you should not be seeing this kind of graph here. This over there, this should not happen. Okay, they should not switch that frequently, because this is what the catalytic converter is for. This, when it's functioning correctly, makes the oxygen sensor have a continuous and smooth reading. It shouldn't be switching all the time like it is doing right now. Okay, see, this is a short time scale. Okay, this is not a long time scale. This is in the order of seconds. Okay, and that should not happen. You should have a reading that's stable, as you saw in the beginning. Okay, basically what this is telling you is that the catalytic converter is not doing much to reduce the hydrocarbons on the exhaust. Furthermore, the upstream sensors, the sensors number 1 on each bank, tell you that how much hydrocarbons are in the mixture. Okay, that's why sensors number 1 and number 2 shouldn't have the same reading, because sensor number 2 is after the catalytic converter, and the value of that sensor number 2 should not match sensor number 1. I want to be as clear as possible, because well, I want to illustrate. This is something that I like. Okay, now sensor, let's see, sensor 1 and sensor 2. Okay, let's merge the graphic. Blue line, is sensor number 1 upstream, and green line is sensor number 2. This is a normal condition, telling me that the catalytic is working okay right now, but once I step on the pedal, sensor number 2 drops and mimics sensor number 1. That should not happen. Okay, that means that the catalytic converter is it's wearing down. It's not completely worn down right now. It's not completely useless, but it's in the process of losing efficiency as we talk. Okay, I'm sorry for the long video. I wanted to be very detailed and very clear about everything, but well, it's your call. Again, what I'm going to do, however, I'm going to proceed with the tune-up. I will do a compression test. Once you have the compression test results, well, it will be your decision. You are going to tell me whether we proceed or not. As for the estimate, it's going to be very similar than the other one. If we do all what I described, I don't. Well, the decision on the catalytic converters, that's going to be up to you again. This is usually more expensive. I don't want to pressure the business into replacing them, but it depends on you. Okay, once there's something else that I'm going to do, I'm going to remove the catalytic converter that's right now on this vehicle, in order to see how it looks on the inside, and then you're going to take a better, more informed decision. Okay, so I'll keep you posted. Let me know.